Here, now I'm going to explain about how to find the solutions of Bernoulli's differential equation. Let dy by dx plus p of x into y is equals to q of x is the general form of the linear differential equation in terms of y variable. But here, whenever the right hand side part is multiplying with y power n, then it is said to be a Bernoulli's differential equation in terms of y variable. Okay, so according to our linear differential equation, the right hand side should have only q of x, but we are having y power n. So because of that reason, for converting the Bernoulli's differential equation to linear differential equation, multiply on both sides with y power n. Then we are going to get divide with y power n on both sides. Then it's going to become like this: 1 by y power n into dy by dx plus p of x into y by y power n is equals to q of x. Then after doing simplification, this y by y power n can be written as y power 1 minus n, y power 1 minus n. Okay, now here, if we observe, what is the general form of a linear differential equation? Dy by dx, dy by dx. The general form of linear differential equation is dy by dx plus p of x into y is equals to q of x. So this is all the things are like that only. But when it comes to here it is 1 by y power n. According to our earlier discussion, dy by dx coefficient should be 1 only. But here it is having 1 by y power n. But again, if we are multiplying this with y power n, then again we'll get our given differential equation, the general form of the Bernoulli's differential equation in terms of y variable. Only because of that reason, we should not convert. Here, I'm going to give very important matter. What we discussed, dy by dx quotient should be only 1. But from here onwards, I'm changing a little bit in the statement of the earlier discussion, that it is just dy by dx coefficient may be 1, or maybe in terms of a dependent variable. What is a dependent variable? Dependent variable is y variable. So it may be in terms of y variable. So you can feel this is dy by dx only, even it is dy by dx coefficient is having other than 1 also. Because that other than 1, it is only in functions of y variable, because of that reason. So now, if we observe, this is dy by dx plus p of x into y is equals to q of x. So all the thing is similarly, but in place of y power 1 minus n, we are in place of y power 1, we are having here y power 1 minus n. So because of that reason, substituting it as a new variable, then if we substitute y power 1 minus n is equals to a new variable z, then differentiate on both sides with respect to x variable, then we'll get it. So if we do simplification, we'll get 1 minus n into y power, what we'll get? 1 minus n minus 1. Minus 1 plus 1 gets cancelled. We'll get y power minus n into dy by dx is equals to dz by dx. dz by dx. Okay, now I'm taking 1 minus to right hand side. What it's going to become? Left hand side is 1 by y power n into dy by dx is equals to, right hand side will be 1 by 1 minus n into dz by dx. Okay, so I'm going to give you a clue point here. The clue is here: whatever we substitute, forget about it. After substitution, if we do differentiation on both sides with respect to the independent variable which is available in our given differential equation number 2, then the left hand side part of our final conclusion will be as it is the first term of our the differential term which is exist in the previous differential equation number 2. Check, both will be same. You substitute anything, okay, you should get like this only. If you are not getting like this, then the substitution what you made is wrong. That means what we can substitute depends on our choice. Okay, we can substitute whatever we require. How to identify that? We will identify in place of y power 1, we are having y power 1 minus n. So substituting y power 1 minus n is equal to new variable. How to identify whether you did substitute it correctly or not? You do the differentiation on both sides with respect to independent variable. Then the thing what we are going to get, the left hand side of the equation should be same as it is, which is available in our differential term of the equation. If both are same, then our substitution is correct. If both are not same, then our substitution is wrong. Then substitute all these things in equation number 2. Okay, so substitute in equation 2. If we substitute in equation number 2, what we are going to get is, what is equation number 2? Left hand side first term is 1 by y power n into dy by dx. So what it will be going to become? 1 minus n into dz by dx plus p of x into y power 1 minus n. Y power 1 minus n we are substituted as z is equals to q of x. Now, if you observe, what is the dz by dx coefficient? 1 by 1 minus n. It is some constant only. N is a constant value. So dz by dx coefficient should be only 1. So that multiply with 1 minus n. Multiply with 1 minus n on both sides. Okay. If we multiply with 1 minus n on both sides, what we are going to get? dz by dx plus 1 minus n into p of x into dz, sorry, into z is equals to 1 minus n into q of x. Okay. Now, 1 minus n is a constant value. Then can I replace 1 minus n into p of x with something p1 of x? Instead of p of x, I am taking p1 of x is equals to z. 1 minus n into q of x, I am taking it as a q1 of x. Okay. Now taking this as equation number 3, I think so. Let me check. That is equation number 2 or 3. Yes, equation number 3 is, what is this equation number 3? Is a linear DE in Z. So how to find the solution of the this? Okay, what is P1 and Q1? Where P1 equals to P1 of x equals to 1 minus n into P of x. Okay, Q1 of x equals to 1 minus n into Q of x. Okay, Q of x. So because of that reason, okay, just for understanding purpose. So now how to solve the differential equation, linear differential equation in Z? You know already the procedure. Solve equation 3 and then replace z equals to y power 1 minus n. Then we get general solution of given differential equation 1. Okay, so this is a procedure. What is this? This is a procedure of Bernoulli's differential equation in terms of y variable. So same manner, I'm giving you method number 2. So this is just for your practice. Method 2. Okay, so let dx by dy. What is the general differential equation of linear D in terms of x? Dx by dy plus p of y into x is equals to q of y. This is linear D in terms of x, but here I'm going to discuss as Bernoulli's D in x. So what we can write, x power n is a Bernoulli's D. D in x. So what we did in our previous case, like Bernoulli's D in terms of y variable, we multiplied on both sides with we have to eliminate x power n here. So because of that reason, what we have to do, divide with x power n. Then we are going to get 1 by x power n into dx by dy plus p of x into x by x power n is equals to q of I. So divide with x power n. On both sides. If we divide with x power n on both sides, then what we are going to get? 1 by x power n into dx by dy plus p of y into x by x power n. But I am writing direct step here. X by x power n can be written as 1 minus x power 1 minus n is equals to q of y into x power n. I just skip a step. Okay, so taking it as equation number 2. Now observe that as we discussed in the previous method number 1, here what we can understand. So here, if we observe that dx by dy coefficient should be 1, or maybe in functions of which variable? Dependent variable. What is the dependent variable? X here. So it may be in functions of x power x variable. So it is acceptable. Okay. So now treat this as differential term dx by dy plus p of y into x is equals to q of. Okay. Sorry. Right hand side x power n should not be there. Here I made a mistake. Okay. So what is the right hand side part? We'll get it. We'll get only q of y. So dx by dy plus p of y into x power 1 minus n is equals to q of y. Now, if we observe, compare with the linear differential equation in terms of x, what it's going to become? If we observe linear differential equation in terms of x variable, then in place of x power 1, what we have here? X power 1 minus n. So substitute this x power 1 minus n is equals to a new variable. Put x power 1 minus n is equals to a new variable. Here also I am taking z only. So on both sides, differentiate with respect to which variable? What is the independent variable in the equation number 2? Y is the independent variable. So differentiate on both sides with respect to y variable. So if we do the differentiation of with respect to y variable, then we are going to get, here it is as 1 minus n into x power 1 minus n minus 1 into dx by dy is equals to dz by dy. Okay, so on simplification, left hand side part will be 1 x power minus n. What is x power minus n? Becomes as 1 by x power n into dx by dy is equals to 1. Bring left hand this 1 minus n to right hand side, then it will become 1 by 1 minus n into dz by dy. Now substitute this one in our equation number 2. So if we substitute in equation 2, what we are going to get? Then equation number 2 becomes as, what is the first term of the equation number 1? 1 by x power n into dx by dy. 1 by x power n into dx by dy here. Okay, as I given the clue in the previous method, so we are getting the same here. 1 by 1 minus n into dz by dy plus p of y into x power n minus 1. What is x power n minus 1? Substituted as z is equals to q of y. So on both sides, multiply with what is that? dz by dy coefficient should be 1, but here it is 1 minus n, 1 by 1 minus n. So multiply with 1 minus n on both sides, then we are going to get dz by dy plus 1 minus n into p of y into z is equals to 1 minus n into q of y. Q of y. Then I am replacing like our previous method, dz by dy plus treating this as a p1 of y into z is equals to q1 of y. So taking it as equation number 3. What is equation number 3? Check it clearly. Is a linear DE in terms of which variable? Z variable. Linear DE in Z, solve and replace Z variable. Okay. So solve equation number 3 and then replace Z. Solve equation number 3 and replace with the Z. What is the Z here? Z is x power n minus 1. Then we'll get the general solution of given differential equation number 1. Okay. So this is the procedure of method number 2. Now I'll just give for your practice 1 or 2 problems here. Okay, only one problem. Solve before attending the next class. Solve x into dy by dx plus y is equals to x cube into y power 6. Okay, you listen once or twice if you require, and you understand this method, solve this problem before attending next class.